Namaskaram everyone, welcome back to the 71st episode of Master Unreal series, and in this episode we are going to start implementing the Lyra system for the character. So up till now we have been implementing the animation side where we created all the distance matching and other stuff from Lyra, and now we are going to take its components and put it into our project. One by one we will draw it from scratch and we will understand how these components are talking to each other, and more importantly how they are making your game or your project modular enough so that you can replace whatever component you want with your own custom style and logic. Okay, so in this episode we are going to make our own character movement component and our own hero component. So in Lyra it is called hero, we will call it pawn gameplay component. So if you haven't seen my previous episode, I highly recommend you check that out, and without wasting any time, let's get started. Alright, so let's discuss the strategy first, how it's going to happen, how you are going to set up your player in a way that it supports and stands on a composition and not inheritance. Okay, and we are going to start with really simple. We are first going to work on the walk, run, crutch, and the combinations of these three. So this is something that we were doing in Tag Manager, and the Tag Manager, as the name suggests, it's not his job to handle your combinations of your movement. Okay, so when it comes to movement, it has to be your character movement component. So we are going to create it, but let's see how we are going to do it. Let's discuss. First is your player. Okay, now every player is a character, which means every character will have a character movement component. You cannot escape from it, and whenever a player comes into the picture, that means it has to be controlled either by your player controller or by the AI controller. And right now we are discussing about the player, so we will assume it is controlled by a player controller, which means input action is in the picture. Now what was happening earlier, you used to press the key, then you used to update the character movement component, like apply the gate speed, deceleration, braking friction and everything, and then CMC was updating the player. Now we are not going to do that. Instead, we are going to create a new component that is your gameplay component. See, if you have seen different type of games, like for example Sekiro or Call of Duty, you can walk, you can run, you can even sprint. There are three different states of locomotion, and the funny thing is, if you are in crutch you can go into run, if you are in running you can go to crutch. So all those transitions are allowed, but in some game, let's say if you are in crutch state, you cannot run, and if you are sneaking you cannot suddenly start running, or sometimes it's a toggle based running, like once you press shift you start running, if you press shift again you stop running, you just go normal walking. The point is you are not holding the key to run, like for example in the God of War. So these kind of gameplay combinations can change over the period of time. Your game can require different type of mechanics, different type of combinations. So we do not want to do that in the player character, because if you go more ahead, you can switch your characters. For example, in Call of Duty, if you have seen, sometimes you are playing as Ghost, sometimes you are playing as Price, sometimes you are playing as Soap. So player controller can possess any character, and we cannot copy the logic from one character to another, because once you possess a specific character, other characters are controlled by AI, so their blueprint is having the input actions unnecessarily. We do not want to do that, so instead we will create this gameplay component, which is not an actor component, it is a pawn component. So when I say pawn component, that means this component can only be added in a blueprint or in a class that is a pawn. A character is also a pawn. It is derived from here. It's just it possesses character movement component and it represents character. So that's why. But the idea is there are two type of components right now: actor component and pawn component. Any actor can have the component, but a pawn component cannot be added in an actor. Okay, so if it is a pawn, now why I'm saying pawn and not character, because your vehicles are not character, they come under the pawn category. Your vehicles, your helicopters, your other cars and bikes and everything that comes under the vehicle, and they are pawn. In that situation also you should be allowed to use this gameplay component. Okay, so summarizing how this flow is going to work, your input action will provide the input, and it will trigger a function in the gameplay component, and that's where you will decide what is the input, what is the output, 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 what is the what you want to do when this input action is pressed. Later on, we will bind the functions with the input action so that this call can be made automatically in the background. But for that, we need gas again, and I'll go there. But first, I want you to understand that your controller is talking to gameplay component. Now, gameplay component will decide what to do and will tell the character movement component that please apply this thing. Once you send this information to CMC, it will send it to player. So both input action and gameplay component do not have access to the player. So your input action is not controlling the player, it is just sending the events, which is the job of the input action or the controller, because you are pressing keys, you are just sending the signal. How that signal has to be decrypted or understood is decided by this gameplay component, which can change as per your requirements. So if tomorrow you come up with something new, you can always replace this component. Your character is still same, your character movement component is intact. All you need to do is just replace this component. And this is the point where you can make different type of variations for your game for different characters. Okay, so that's the idea. Let's implement it. So first of all, to have the pawn component and not the actor component, you need to enable a plugin. So this is something which we are going to use a lot, and it is called Modular Gameplay. Okay, so we are going to use this. And this has the base classes like pawn components and other subsystems to support modular use of the gameplay framework, which will come in the next episode. So I'm going to enable it and restart it. Okay, so once it is done, we will create a new base character class. We are not going to rely on this inheritance where you have character default, from there you have a player, and from character default you have AI default, and from there you have the characters. So we are not going to follow this inheritance hell, and I'm going to show you how the composition can provide you a better control over your gameplay mechanics. Okay, so let's go and create a base character class in C++. I know we already have one, but I'm going to create a new one. So consider this character and call this base game character. Okay, and I'm going to open this folder and I'll create a new folder and I'm going to say character. Everything that is connected with the character and part of our gameplay mechanics will be in this folder. So I'll select this and create the class. Okay, you are going to get this warning. Let's press yes. You can go to your project and you will find your character base character.header file. Okay, and I can go to base character.cpp. I'm going to remove this character because this header file is in the same folder. I'm going to go back, hit the live coding. Okay, once it is done, we are going to create a new base player class. So right click, blueprints, and select for base game character and name it BP base player. Okay, now I know we already have the player, but we are going to start again and we will migrate whatever we have step by step. In a way, it supports composition. Now let's open this up. And the first thing we need is the character mesh. So I'll quickly add it. Then we have SWAT soldier with us. Let's rotate him. You can increase the capsule half height a bit. Next thing we need is the character movement component, our own character movement component. Right now it's one from the Unreal. So again, go for tools, new C++ class, all classes, search for character movement component, and I'll say base character movement component. And I'm going to place it in my character again, create the class. If you see this, press on yes, it's fine. Go to your project, you will find the base character movement, and in the CPP, remove this character because header file is in the same directory as well. So now you have your character movement. Now let's tell our character, base game character, that we have to use this character movement component. So for this, I'm going to create a new constructor that comes in build, and I'll say f object initializer. Okay, and I'm going to click on this, generate the definition. So this created constructor for us. Great. Now we are going to call the parent class and we are going to tell that, hey, object initializer, please set the default sub object class. And what is that class? So I'm going to pull this down and I'm giving my base character movement component. Okay, and we are going to say a character movement component name. Oh, it should be Unreal base character movement component, and let's include its header. So this will tell the character or the Unreal Engine that please use this base character movement component for character movement component that you have in the character by default. And we are going to create that movement component in our base game character. So under the public, I will say u base character movement component. Okay, and I'm going to expose it. So u property, because this is a variable, and I'll say it's visible anywhere and it's blueprint read only, and the category is character movement. Okay. Oh, we have not included this class. So one way is you include it, another way is you forward declare it. And I always told you, if you are not accessing anything from inside the class, you can just declare it. So I'll just declare it. And we are going to initialize this movement component in the CPP as the constructor works out. Base character movement component, and now you need the movement component, so get the movement component. Okay, so this is a parent method that comes in every character. This will get the movement component, and we know that this is our base character movement component, so we'll cast it and then we will store it. Go to your project, hit the live coding again. Once it is done, go to base player. You see component class has base character movement now. Great, let's test. What I'll do, I'll create Gait. So one way is you go in the tools, new C++ class, select none, and create a class movement state types. Okay, and we are going to store it in public folder so that everyone can access it from anywhere. Once you do that, you come here, you remove these two, you go to the public private, and in the private you have the CPP, in public you have the header file. Remove this. Now we are going to create an enumerator. So first of all, you will say it's a enumerator and it's a blueprint type. Then you are going to say enum class egate uint8, and the first is walk. Then you have first is walk, then you have run, then you have sprint, and like that you can go on. Maintain the order of these movements, like walk is the slowest, run is faster, sprint is much faster. Let's say you have sneaking, so you will go sneaking like this. First sneaking, then walk, then run, then sprint. So let's say you are in a crouch position or you are leaning to a wall. In that case, the maximum, let's speak in terms of speed. The maximum speed you can have is the sneaking speed. You cannot walk, right? The sneaking is little slow movement, but walk is little fast movement from that. Let's say you are in a crouch state. In that case, you can go into sneaking, you can walk, but you cannot run. Okay, I'm just saying the example. So arrange the enumerators in such a order that every next enumerator is greater than the previous one. So right now I'm not going to have sneaking, nor I'm going to have sprints. Let's only work out with walk and run. And you can also add the meta description. Okay, so this is a small display name that will reflect in the Unreal editor. Great, now let's include this in our base character movement.h. I'll create protected variable. First is egate. Remember to include this header file, and I'm going to say current gait. Okay, what is the current gait as per the movement component? Now second thing is the desired gait. Let's say you press shift to run, but you are in a sneaking state, you cannot run. So in that case, you will just set your desire, which you got from the controller, but whether to act upon it or not will be decided by you. And let's say you are falling, okay? In between that, you cannot crouch. So even if your gameplay mechanics allow to crouch or to run, at the time of falling, you cannot do that. And that's the job of the character movement component, to make sure that you are on the ground before applying any gait or change any gait. So what I'm going to say, egate desired gait. All right, so these are the two variables that CMC have to have. And I'm going to create public getters so that you can get their values. So I'll say egates get current gaits, and it's a constant function because it is not modifying anything. And let's create a function to set the desired gait. desired gait and you provide the new desired gait. Okay, and I'm going to create its implementation in C++, and I'm going to say desired gait to new desired gait. Great, let's see whether this function is there or not. For that, we need to first of all make sure it's blueprint callable, and I'll say category movement, to be more precise, character movement. And this is also blueprint callable. Come back to your project, hit the live coding again. Oh, I made a mistake. It should be U integer, unsigned integer 8. And now hit the live coding. Okay, once it is done, you can go to your base player, and now you can get this character movement component by compile save. And you can say get current gait, which is not appearing, so that's funny. Okay, we made a mistake. There cannot be two constructors, so I'll just remove it, and this one as well. Let's go back and hit the live coding again. Okay, now you go to your base player, get the character movement. Okay, so it's not refreshing. So what I'll do, I will go to my class settings and first change it to character. Okay. Okay, once you do that, you go back and go for base game character, and it will show up the movement component. The name will change. Okay, so now if you get the current gate, you are able to access the functions. All right. Now, for those of you who have been following me in the Master Unreal series, you know we have these gate settings. So we have defined the parameters for walking and running. So we are going to set up this in our character movement component, not in the character class. So I'm going to go in movement state params, and I'm going to create a Struct blueprint type, f gate params, generated body, because this is going to be in blueprints. And you can define all those 4 variables here. Okay, so max walk speed, max acceleration, deceleration walking, braking friction factor, braking friction, and use separate braking friction. Okay, so this is your gate params. Now let's access it in the character movement component. Under the protected, I will create this map of e gates and f gate params. Okay, and I'm going to name it gate settings. And now by default, your current gate will be set to walk. Okay, and desired gate will also be set to walk. All right, and now this variable is allowed to be edited, and if you want to change the gate settings or add more gates with their parameters, then what you can do, you can expose it to blueprints, edit anywhere, and it is blueprint read only. That means you cannot update them, you can just read them, but if you want to edit, you have to come into the editor. And I'm going to give the same category, that is your character movement. All right, now let's add the walk and running by default in the base character movement.cpp. We need a constructor. So for this, I am going to create a constructor in the public. So we will create one more function that will apply the gate parameters, because other entities will also need it. So let's create a function that can update the gate parameters. I'll say bool whether the gate parameters are applied or not. Apply gate params and provide us the gate. So gate, okay. And let's generate the definition. First of all, we will check whether this gate is present in the gate settings or not, because if it is not, then how we will set the values. So I'll check if gate settings dot contains this gate. Okay, if it is not there, then return false. We cannot apply it. Next up, we want to get this parameters if it exists. So I'll use gate settings and get me the gates. So what does this gives you? It gives you f gate parameters, and I want to take reference, not copy, and I'll say params. And now we can set all the parameters. So we are inside the character movement component. So there is a variable called max walk speed. We'll set the params.max walk speed. And like this, you can set all the 6 parameters just like this. Great. And you are not supposed to modify the parameters. So I'll mark it const so that later you do not modify it or any other developer does not modify it. Awesome. So there is a function that can apply the gate parameters, and I'm going to return true because I applied successfully. And now when the event begin play happens, I want to apply these gate parameters. So let's go and create a begin play, protected virtual void begin play, and we are going to override it. Let's create the definition. So first we follow the parent implementation, then we provide our own thing. So we'll say apply the gait parameters and the current gait, which is set to walk. Okay, so we are getting issue in the generated body of the movement state types. We are using the generated body, but we have not included the generated header file. So I'll include that movement state types.generated.h. Now hit the live coding. Okay, so the compilation is successful and now we can try. Okay, just to test, we will get this movement component and get the current gate and we have everything working. Okay, cool. So let's see how we can send the input actions. So for that, you need another component that will talk to the CMC. I'll go tools, new C++ class, search for pawn component. Now you see it is derived from the actor component, then game framework, and then pawn. So it is an actor component, but this is more focused on pawn. So we'll say pawn component. Now this can only be added in pawn, or at least you should be adding this in pawn. Pawn gameplay component. Okay, and I'm going to place this in character folder. Okay, after a refresh and this processing is done, you will see your pawn gameplay component.h. Great. So let's go to C++, remove this prefix, we don't need it. And now this is where the magic will happen. So first of all, I need to expose the functions. So the first function is for movement. So void input move. And we are going to do the same thing that is happening in the player. If you go to the top, this is the move. So you see when you move, you are taking the action value vector, splitting it, and then you are adding the movement input in the controller. So I will expect a 2D vector and reference of it constant so that we don't modify it, and we'll say input action value. All right, then I can create two more functions, input crutch const boolean, and we'll say input action value. Then we go for input underscore run, again boolean. So okay, now I told you movement component is having a current and a desired gate, but your pawn gameplay also has to decide. So I told you when you are leaning onto the wall, the maximum speed or the gate you can have is the sneaking. But if you are in a crutch state, then you can go sneaking, running, crutching, then you can go up to run, sprint. Okay, so that calculation whether this gate should be allowed in this game situation or not will be decided by the pawn gameplay, and whether it can be applied in the current state will be decided by the character movement. So these are the two things that you need to keep in mind. So I'll create three variables. I'll go for current gate, which is walk. I'll go for desired gate, which is walk by default. And then there is another gate that is called max allowed gate. And that is run, the highest gate you can have at that moment. Okay, now whenever you press movement input, crutch or run, someone has to update the gate. So we'll create a function to update the gate. Now this function will decide which gate have to be desired based on the current gameplay state. And then whether it is possible to apply it will be decided by CMC. So let's implement their logic. Okay, so I have created the definition in CPP by default so that we don't waste time. Now let's start from the input move. Now this is what we have to do. First of all, we need the pawn. Get pawn, which comes with this pawn component. Okay, and you will say a pawn. So this will give you the owner of this particular component. And we have to store it. So a pawn pointer, and then we'll say pawn. And like I always say, check the pointers. So if the pawn is valid, then we need to get the control rotation. Now, one way is you do the if else. Another way is you use the ternary operator. So I'll use the ternary operator. I will say if the pawn is valid, then get the controller that is controlling this pawn. Otherwise, give me null pointer because there will be no controller since the pawn is not valid. So I'll say, okay, it's a controller. So I'll store it in the controller variable. Now I will check for this controller variable. If this is not valid, then return. That means we cannot proceed. But let's say if the controller is valid, then we are going to store a rotator. So F rotator, movement rotation. And now here you can provide the roll, yaw, and pitch. So the roll will be 0. Yaw, it will be the one that controller has. So controller, it's a pointer. So get the control rotation. And X is the yaw. And pitch, it's going to be 0.0f. So if the X direction is not equals to 0, that means the character wants to move in the X direction. And we will create the rotation. So movement rotation dot rotate vector. So I'll say F vector, right vector. Now we need to store it. So this is a vector type, F vector, movement direction, and let this be const so that you do not modify. Now you add this pawn input movement. So add movement input, movement direction. Now do the same thing if the input action is in Y also. And in the movement input, you have to provide the intensity. So that would be input value dot X. And in case of Y, okay. So there you have your moment input added. Now, if you want to run, you have to set the desire for run. So first I have to check if your character is running. So that means I have to talk to CMC whether you are running at this moment or not, because we cannot rely on this current gate, because like I said, you may desire for some gates and it might not have been applied by the CMC due to any reason. So what I'll say, get me the movement component. So first of all, I have to get the character. So I'll get the pawn and I'm going to provide my A base game character. Okay, so it's going to return me the game character object reference. So if this is true, then I would like to store it in a variable. Now there are two ways. One is you store in this style. Another way is you store it in a if. So I'll say if a base game character pointer, and then I will say character is equals to. This is also a way. The advantage of this is like as soon as the if block code is over, the character will be destroyed from the memory. Okay. In this situation, this pawn variable will be released from the memory when the function is all over. So I'm just telling you another way of having the character. You can also do this way, not a problem at all. Now I would like to get the movement component. So get the movement component and we are going to cast it to our U base character movement. So if the movement component is not valid, return. But if it is valid, then we would like to check. So if movement component get the current gate, if it's equal to E gate run, then we would like to stop him from running. Okay. But let's say if he's not running, then we want him to run. At least we desire to run. So we will store this result in the desired gates. Okay, so if you are running, then make you walking. If you are not running, then we will make you running. But this is what we desire. We have not yet implemented it. So once the desire is calculated, we would like to call the update gate, which will decide based on the gameplay situation, can we have this desired gate? If yes, then pass it to CMC. Let's talk about the crutch. So again, we will check our character. And now we have to make our character crutch and uncrutch. Now here we would like to get the character again. So I'll copy this here. So if the character is valid, then we would like to request him to crutch. Or if he's already crutched, then it will uncrutch. So for this, I'll create a function in the base game character. Under the public, I'll say void toggle crutch. And let's implement its definition. So first of all, we will check if you are already crutched. So the character already has a variable. You can verify it from the base player. Like if you right click in the player blueprint, you will see is crutched variable. So we will check that here. If you are crutched, B is crutched, then we would like to uncrutch. Okay, so uncrutch. But let's say if you are not crutched, then we want to check if you are on ground, because this ability can only be done at the ground. If you're falling, then there is no point. So in this situation, we have to ask the movement component, are you on ground? So we'll say is moving on ground. Okay, so if you are moving on ground, then we will crutch. Okay, so now we are going to call this function in our gameplay component and we will say character toggle crutch. Okay, Now, whatever is the situation, just make it opposite. So let's talk about the update gate now. So right now we have walk and the run state. So I'll think according to them. So there is only one side effect that we have to tackle. We have to check if you want to run. That means if your desired gait is to run and you are crutched, then in that case you would like to uncrutch. So for that we need the character reference. So I'll get the character here. I'll check character. B is crutched, and if you are crutched, then we will make you uncrutch. So we will copy this and paste it here. Now we are not changing your desire, we are just changing our character back to the uncrutched state if he is crutched. Okay, and let's say you are running, okay, and in middle of that you press this crutch key, then you would like to desire for walk. So I will say desired gait to walk, which is gait walk. Remember, you are not allowed to set the maximum gait. That is the demand of the situation, which will be triggered by the gameplay effect or ability or something that will put this restriction. As a player controller, you can just set the desire. So if you are running and then you pressed control, then we would like to limit to walk. So now there is another situation. We have to check whether the desired gait is within the maximum allowed gait. If the desired gait is greater than the maximum allowed gait, now you have to use integer, you have to convert them so that you can get the index. In movement state, I told you to arrange them in the ascending order. So if you are, let's say, desiring for sneak, for a second, just assume. Now this is how these are arranged. Now let's say your maximum is set on walk. That means maximum gait is set to index 1, and now you request to run. It will not happen because requested is greater than the maximum allowed. All right, so that is what we want to do. We want to place this check so that you do not exceed the gameplay situation. So I'll go to pawn gameplay component and I'll say convert this enumerator into the integer so that I can do the comparison. So if the desired gait is greater than the maximum allowed gait, then we would like to set the desired gait to max allowed gait. We can go up to this point only. But if it is less than or equal to, that means you are within the required range. So you can do whatever you want. I'm making a scalable solution, although I just have two state, but I'm just suggesting it. So everything is fine. We have to send this request to the movement component. So what I'll do, I'll get the movement component here and I have to create a function there. So I'll create a public function for a desire. So I'll say void set desired gait. Okay, and let's implement the logic. We will say desired gait is equals to this incoming gait. Okay, we will go back and we will call this movement component set desired gait, and the desired gait is this. That's our job. So when this gait should be applied, this should be applied when you are walking or you are on the ground physically. So there is a function in character movement component which is overridable. It's called physics walking. Okay, so physics walking. All right, and now you are going to override it. So we will say whatever the definition is, implement it. Then only we would like to apply the gait, because if you are not on the ground, then the speed parameters and everything will not be valid. And if you are not walking, this function will not be called. So the gait you desired for will never be applied, and it will be perfectly synced when you will do the replication. So I'll say apply the gaits, and the gait is the desired gait. And now we will update the current gait because it has been applied successfully. Okay, so this is the procedure. Now let's go back and third person map, hit the live coding. Okay, so what I'm going to do, I'm going to take this camera look with me in the base player, and let me remove this, paste it here. This is my look, camera look, and I'm going to remove this branch for now. And I need the input action of running. So input action events run, and I need the IA crutch. Okay, these are the two input events. And now when you press it for the first time, I have to first add that gameplay component. So I'll go back and in the pawn gameplay component, and I'll make it blueprint spawnable. So let's make it blueprint spawnable and put it under the custom class group. And I'll also expose them to blueprints. So U function, blueprint callable, and category pawn gameplay. Okay, and let's expose. Okay, so I've exposed them. Let's go back and hit the live coding. Go to base player, add the pawn gameplay component here. And now you can go for run, input run when you are starting it. Now first we will do the hold style and then we will do the toggle base. Okay. So when you are doing the holding base, then we will say make literal bool and we will pass true. And when you complete or cancel, we would like to stop you from running. Okay. This is when you want to hold the key while running. Now let's go for crutch. When you press it, let's get the gameplay and search for crutch. For now, just pass anything. Anyway, you are not using it. You are checking the character's truth state value. So it will not be considered anyway. I added it accidentally. Okay. Now this is done for look, run, crutch, and we need to get the move as well. So IA move. These are the input actions that we have already created in the actions. And I'm going to get the pawn gameplay and I'm going to say input move. And in the triggered, we will pass the action value. All right, so compile, save. So check the world settings here and search for the game mode that you are using. Change this BP player to base player. Okay, save and compile. And we need the camera, so let's quickly add the camera. And we need the spring arm, so let's add the spring arm here. Okay, and let's pull it up. And we also have to link the animation layer for now. So link anim class layers, and we are using the unarmed layers. Okay, and we need the controller to be binded. This has to be done by the gas and the other components, but for testing, I'm doing this. So I'll go to player and I will copy this. Player controller, enhance input action, then add the mapping context. So let's do that. Okay, so now you go under the character movement and you search for gait settings, and you can add. Okay, we don't need sneak, so I can remove this. Okay, you can copy these values. These are exactly the same we did for the player. And it is not crouching because you have not enabled it. So you will say it can crouch. Okay, so compile, save, play again. You walk, you crouch, you can start running, you can stop running, you can run, and you can crouch. Now you can see it's still walking, not running. If you crouch, it goes back to walk. Now how to do toggle base running? You go back in the base player, and instead of running it on cancel, you just remove it and you just call the input run. That means you want to run. So if you are running, it will make you walking. If you are walking, then it will make you running. So if you press shift, it starts running. If you press shift again, it starts walking. If you press shift, it starts running. Press control, goes walking. If you stop, if you press control again, it's running again. Okay, so that's how your desired gaits work. Alright, so that's it for this video. I hope you enjoyed it. Do let me know in the comments if you have any doubts, queries, suggestions, or feedback. And in the next episode, we are going to start injecting the player state gameplay ability system so that you can bind these input actions and you can remove them from the player. Remember, our entire goal is to make the character blueprint free from any logic that can be extended or changed in the future. So if you like my work and you want to support me, the Patreon and the Coffee link is in the description. All the assets that are used in this series are available for free on the Discord. Feel free to join it, and I'll see you in the next episode. Till then, you take care. Bye bye.